Okay, so now we are going to discuss the cross product and dot product of a vector, of two vectors actually. Dot product. First of all, dot product. You can also refer to it as scalar product. So suppose before starting dot product, let us understand the concept of projection. In Cartesian coordinate system, suppose this is a vector A. Now just imagine sunlight falling from here, then because of this sun rays or because of this light rays, you can say that image formed of vector A on x-axis would be this. Up to it would be confined to this limit, and the length of this image you can find if you have the angle theta of A with respect to x-axis, that is theta. So you can say that this length of this image would be A cos theta. Now this A cos theta is said as projection of A, vector A, on x-axis. So now if I discuss the concept of dot product A dot B is simply defined as modulus of A multiplied by modulus of B into cos theta, where theta is the angle between the two vectors. So suppose I am having vector A and vector B, and if I am having angle theta, then I can say that dot product A dot B is simply modulus of A multiplied by B cos theta. Now you can say that B cos theta, from this analogy, you can say that B cos theta is simply the projection of vector B on A. It is projection of vector B on A, where theta is the angle between vector A and vector B. Or on the other hand, you can also say that A dot B is B multiplied by A cos theta. In this case, you can say that dot product is the B multiplied by projection of A on B. In either way, the meaning is same. So, and also this is known as scalar product because the result is a scalar quantity. Suppose I am having two vectors, let's say for example 5i plus 2k plus 2j plus 6k, and vector f2 which is 6i plus 7k. Suppose j it is not having any component in y direction, vector f2, so f1 dot f2 would be equals to 5i plus 2j plus 6k dot 6i plus 7k. Now in this case we can have, since these are the components of given vectors f1 and f2 in x, y and z directions, so you can directly have the dot product of the components in x, y and z directions respectively. So along I it would be 5i dot 6i plus it should be 5i dot 7k plus 2j dot 6i. Similarly, now you can see here that these vectors which are perpendicular to each other, unit vector I is directed along x-axis and unit vector k is directed along z-axis. Here unit vector j is directed along y-axis. So these are perpendicular to each other. So when you take dot product of these vectors, it would be 5i dot 7k would be 5 multiplied by 7 multiplied by cos of 90, which is actually the angle between x and z axis. So cos of 90 would be 0. So you can say that dot product of vectors, those are represented in their component forms. You can directly take as the dot product of their components as the summation of the individual products of x components, y components and z components respectively. So it would be simply 5i dot 6i plus 2j, since here is no component in y direction, so you can represent it as 0j plus 6k dot 7k. So here 5i dot 6i would be 30 into 5 into 6 30 multiplied by cos of 0, because angle between unit vector I in this case and unit vector I in this case would be obviously 0. Here also 2 multiplied by 0 would be 0, and 6k dot 7k would be 42 multiplied by cos of 0. So it is simply 30 plus 42, that is 72. This is a scalar quantity which is having units same as f1 and f2. Now we will move further on towards cross product of two vectors. Cross product is also known as vector product because it yields a vector quantity as a resultant. Suppose these are two vectors A and B lying on a same plane that are having angle theta between them. Then cross product of A cross B is equal to AB sin theta, where theta is the angle between them, and the direction of this new vector is perpendicular to the plane of direction in which these two vectors are lying. So and also its upward sense or downward sense is decided by the right hand thumb rule that we'll just discuss after this topic. But first of all, let us understand what does this A cross B represent. A cross B is actually, it gives a vector as a resultant quantity that is having a direction perpendicular to the plane of direction of these two vectors, and where theta is the angle between the two vectors. So in right hand thumb rule, suppose you are finding out A cross B, then this is my right hand. You need to call your right hand from vector A to vector B. So here is my vector A and here is my vector B. So I will curve it towards B. And now you move your thumbs up or down in whatsoever way it is pointing upwards. So here it is pointing upwards. So I need to show this by upward arrow. If it would have been B cross A, then obviously I will curl my fingers from B to A and my thumb will be pointing downwards. So the direction of B cross A would be opposite to the direction of A cross B, and obviously their magnitudes are going to remain same, and that is equals to modulus of A multiplied by modulus of B and sin theta. So these two vectors are having opposite direction but same magnitude, so you can more precisely say that B cross A is not equals to A cross B. Whereas in the case of dot product or scalar product, we were having A dot B is equals to B dot A is equals to AB cos theta.